So in this video we are going to study about variable length subnet masking, that is VLSM. So basically हम लोग इसका यूज़ तब करते हैं जब हमें डिफरेंट स्ट्रक्चर का सबनेट बनाना होता है। ठीक है, जैसे कि मानो कि हमारे पास कोई एक नेटवर्क है, मानो कि ये एक ऐसा नेटवर्क है और हम चाहते हैं कि इसको इक्वल पार्ट में हम लोग इसको डिवाइड ना करके हम लोग कुछ इसको एक अकॉर्डिंग टू द कैपेसिटी और आवर रिक्वायरमेंट्स हम लोग इसको डिवाइड करते हैं डिफरेंट अनइक्वल पार्ट्स में, लाइक in this way, anyway, where the division is not equal. Okay, so this is the meaning of variable length subnet masking. Okay, so I am taking one example so that it will be easier for you to understand how we do variable length subnet masking. Okay, suppose we have a very big network like this one, and we need we need a network where the number of hosts, the first requirement is the number of hosts should be greater than just suppose 120. Okay, and second, the number of hosts greater than 60. Similarly, number of hosts greater than 60. Okay, so as we know, the the first part, that is the 120, that we need to achieve 120 number of hosts in a particular network. So we just start by dividing in a equal manner, that is equal division will be there. So take it as a network of like 255.255.255.0. Okay, this is the class C network. Okay, so now as we know, as you have already learned in my previous video, that if we divide a network into equal parts, then in class C network the first 3 parts is not disturbed, and the last part, which have 8 digits like 3, 4, 5, 6, 7 and 8. Okay, this will change and this will decide how many subnet will be there. Okay, and how much will be the range of that very subnet. And for this one also we have 255.255.255.8 digit places. Okay, so as we know that if we divide it into 2 parts, then the first digit of the 8 digit we have to fix. Okay, as it is the first part, we will put it 0 here, and it is the second part, so it will be 1 here. Okay, so now we have to divide, we will check if we are getting 120 or not. Okay, so for this network, if we try to draw, I'm writing here the first, then that very network will range from 255 to 255.0. the first one it will be. Okay, 0 will be fixed, 0 0 0 7 times 0. Okay, this will be the first, and the last one will be what? 255.255.255.0 111 111 1, that is 7 times 0. This is basically a 0, okay, and this is what all are ones except the first digit. So we will try to just find out the what will be the decimal number in place of this. 255 is represented by all ones here, so 1 is not at the first place, that will be minus 128. So we are getting what, 127, right? So this is 127. So the range of this network is from 255 to 255, the 255 0 to 255.255.255.127. So as we know that the first and the last one are used up in network ID and a broadcast address respectively. So we will subtract these two ID IP addresses from these collections. Okay, the total number of collection is what, 128, and minus 2, that is 126. Okay, so there are total how many ways or how many hosts will be there in this subnet? 126. Okay, there will be how many hosts? There will be 126. So our first requirement, that is the number of hosts should be 120, is satisfied through this division. Okay, now our second requirement is number of hosts should be 60, should be greater than 60, sorry, should be greater than 60. Then we will try to divide one of it part. You can divide any of them. I will try to divide this one, as I have written everything in this side only, so I will try to divide it here. Okay, because it is clear here. So after dividing, as I have already discussed, that after division, the number of division it should be, then, and if suppose there are total n number of division, okay, n number of division is equal to n, then the number of digits fixed will be n minus 1. Okay, as you can see here, we have divided it into two parts, so the number of digits fixed is 2 minus 1, that is 1. Okay, and here also we have fixed the first digit only, and here also we have fixed first digit only, so it is verified. So we are dividing it into three parts now. Okay, like 1, 2 and 3. So we will try to just get the number of fixed digit. 3 minus 1, that is 2. As so we need to fix two digits. As we know, the first digit is already fixed, so we need to fix extra one digit, so that we could find the range and the IP addresses probability for this subnets. Okay, like suppose the second digit is 0, and for this subnet, that is S2, and for the S3, suppose it is 255.255.255.11, then how many digits will be there? 6 digit. Okay, so any host will have the first two digits as this only in this subnet, and any other host for having this IP address will be relatable to this subnet only. Okay, so we can find the different ranges for this subnet and for this subnet as well. So let's find for subnet S2. Okay, starting is what, 255.255.255.10 0 0 0 0 0. How many zeros is there? 4 and 4. Okay, 8. 2 255 255.255.1001. Okay, so this is the, as we know that the first two digit will be fixed, so here also we have fixed the first two digits. So it will range from 2, that is its decimal number is 255.255.255.191. Okay, and here also it is 255.255.255.128. so it will range from 128 to 191. If you will divide, then you will get that the total number of ways that it can change is total 64. Okay, as we know that 6 digits are changing. 2 to the power 6 is how much? That is 64. As I have already told you that the first and the last IP addresses are used in network ID and the broadcast address for that very particular network or the subnet. Okay, so this will be not counted as a host, so we will minus it here. So we are getting 62. So our second requirement, that is the number of hosts should be greater than 60, is also verified and it is applicable here. So we can divide we can get the first two requirement by dividing it in this form. So now I will check about the last one, that is 60. So for subnet S3, the first one is how much? 255.255.255.1100000, and the last one is 255.255.255.11111. No, it's not net. Then it will be 192 to how much? This is 255, right? So from 192 to 255, it will be 64 ways. Okay, in similar way we will subtract the first and last, that is -2, that is 62. So we are able to get this requirement also here, 62 ways. So this is all about the variable length subnet masking. You can find the different subnet mask router subnet mask at this point. Okay, by counting the number of digits have been fixed, like for this one is 1, so the subnet masking for this router will be, for this network will be 255.255.255.128. okay, so in similar way it will also change that, like 111, then 00, then 6 times 0, then it will be 192. So the subnet mask for this these two subnet mask will be what? 255.255.255.192. so this is all about variable length subnet masking. You can see we got the division according to our requirement. So thank you for watching.